Hello, my name is Farhiyo Awale, and my project is on the effects of piracetam on adult zebrafish. So you're probably wondering, what is piracetam? Well, piracetam is a nootropic drug which is known for enhancing memory, concentration, and mental alertness. It is widely used in Europe and is prescribed for restless disorders like ADHD, anxiety, and Alzheimer's disease, though has yet to be approved in the United States. The objective of my project is to investigate the impact of piracetam on anxiety levels on adult zebrafish. I set up my experiment so that the zebrafish were injected with different piracetam concentrations, which were 0 milligrams per liter, 200 milligrams per liter, and 700 milligrams per liter. I then measured how stressed they were by observing their swimming patterns. The variables I measured were latency, which is a hesitation to enter the top zone, and the time spent in each zone. So the behavioral observations I've made were that zebrafish were less hesitant to enter the top zone and spending more time there had reduced anxiety levels. And zebrafish with increased latency and more time in lower zones displayed higher anxiety levels. The reasons why the ones in the lower zones had higher anxiety levels is because they are afraid of what lies above and therefore stay to the lower areas. The results have shown that piracetam treated fish spent significantly more time in the top zone than untreated fish. These findings have potential for further research on piracetam's impact on humans with cognitive disorders like ADHD and learning disabilities. So you're probably wondering, why have I chosen zebrafish? Well, zebrafish share 70% of their DNA with humans, making them efficient subjects for chemical and biological experiments. Previous research on zebrafish by Leah Grisman revealed that accurate piracetam exposure did not affect behavior at mild doses, but showed behavioral restraint at higher doses, which were like 700 milligrams per liter. This shows that in smaller dosages, piracetam may not be visible in bodily functions, but when in higher dosages, you can visibly see the calmness taking over on the organism's body. The independent variable is the piracetam, since it is causing the change, while the dependent variable is the fish's cognitive sensitivity altered by the piracetam. So the materials and methods that I've used is a stress coat to distill the water, since regular tap water is dangerous for zebrafish, 3 fish bowls to divide into trials and into concentration groups, a balance to measure the piracetam, filter paper to put the piracetam on for the balance, a logbook for my equations, a measuring spoon to measure the piracetam, Ziploc bag to place the piracetam in, and 3,000 milligrams or 3 grams of piracetam, along with 9 zebrafish, which are split into 3 trials, so 3 in each group. A diving tank, which is then divided into levels, showing level 1 as the highest and level 3 as the lowest. A graduated cylinder filling up to a liter in each fishbowl. A fish net to regularly clean the fishbowl, and fish food. As you can see in my images, I measured piracetam concentration using a balance beam and filter paper. Right here, you can see this filter paper with the piracetam on it, and it measures exactly 1 gram of piracetam. Here is the image of the pure piracetam shown. I measured 1 liter of water using a graduated cylinder right here, and I placed it into the fish bowls. This is a picture of the fish in the fish bowl, swimming in the fish bowl. And also, I labeled the fish tank and divided it into 3 parts. So as you can see here, level 1 is the highest, level 2 is the middle area, and level 3 is the lowest. The fish that were residing here were scared, and the fish that were up here were not scared of the predators or what lied above. The fish were briefly exposed to stress by tapping on the glass here, and then I placed the fish into the tank and recorded them for 5 minutes and observed them. I disposed them using the ice method, which is later be explained in the procedure. And this was all repeated for the different trials. All pictures were taken by me. Throughout the procedure, I followed these exact steps. At first, I prepared the piracetam dosages. I measured and prepared them using the balance beam, and I separated them into 200 milligrams, 700 milligrams, and 0 milligrams for the controlled concentration. And then I allowed the zebrafish to swim in the treated water for 10 minutes to ensure the environmental exposure to piracetam was secure. I established concentration groups by creating the 3 groups, and then I tapped the glass to alert and scare the fish, which created the stress factor. I recorded the fish behavior for 5 minutes, and as they responded to the stress-induced stimulus, I then rewatched and observed the fish in the video. I carefully observed and tracked the behavior of the zebrafish to assess the impact of piracetam on stress relief. After that, I disposed them using the ice method, which is to prepare a bag with regular ice and immerse in a small container filled with fish water. I placed the fish in a bag and refrigerator for 1 hour to euthanize them and remove the bag and dispose the water and fish mixture by flushing it down the drain. As you can see here in the data, this is the overall average. So for the control group, the latency, the hesitation to reach the top was very high. It took them a long time to get to level 1. In the 200 milligrams group, as you can see, it didn't take them that long in trial 1, but trial 2, it took them some time along with trial 3. And the 700 milligrams group, they swim very fast to the top. As I put them into a tank, they swam and skyrocketed there. So figure one shows a control group, and as you can see, the latency is little high, and this time spent in level 1, 2, and 3. As you can see, in level 3, the lowest area, that's where they spend most of their time there. And for level 2 and level 1, they just dip back in and go right back down to level 3. For 200, you can see that the latency is a little bit higher, but it's smaller than just a control group. And as you can see that the fish in level 1 and level 2, that's where they spent most of their time there. While level 3, this lower area, they have not spent much time there because they're calm and they feel more free to swim about. And in this one, the highest concentration group, 700 milligrams, you can see these fish spend most of their time in level 1 and second part in level 2, but rarely in level 3. And latency was very, very small. You can see they skyrocketed into the top the second I put them in. So this shows that the control group, the fish spent most of the time in level 3, averaging 73 seconds in level 1, 75 in level 2, and 151 seconds in level 3, which is almost double the time. This shows that they're very anxious. For 200 milligrams, they spent most of their time in level 2 and barely in level 3. So they're not that scared anymore or anxious. But in the 700 milligrams one, the fish spent most of their time in the highest level, level 1. On average, the fish stayed in level 2 for 114.3 seconds and in level 3 for 61.33 seconds. And in level 1, they spent 124.33 seconds in their surface area, not worrying about anything. This helps prove the hypothesis of piracetam calming you down and improving your stress response. In conclusion, the results of my experiment strongly suggest that the piracetam concentrations have a notable impact on behavior of fish. This shows that the decrease in latency times shows that the heightened state of tranquility, meaning that the fish are more calm. This shows that piracetam had a great role to play in that. As you can see, the differences between the control group and the 700 milligrams group, they had very different swimming patterns. This was a very successful experiment. In ways it can go better is by using higher tech measuring devices, such as automated pipettes, instead of using a balance beam or like measuring it with measuring spoons. And also we can do it in a laboratory, and we can also use humans for clinical trials to see how it differs from the zebrafish. I'd like to sincerely thank the people who have helped guiding me through this experiment, such as my science teachers, my sister, who's currently in science, and also the director of the UMN biological labs, Michael Jarko. He's supplied most of my supplies for me and has answered every question that I had. So here's my bibliography. It's helped me see how I could treat the fish and also why I chose zebrafish, along with watching Leah Grossman, who has also created and conducted a similar study showing the effects of piracetam on the behavior of the fish. Thank you for listening to my presentation, and I hope you enjoyed it.